Hello, guys. Welcome back to Maths on African Motives. Still on our Mathematics N6, and this is the part of our Center of Fluid Pressure. We just want to check August 2023 exam. It's a nice question. This one, a very, very nice one. I consider this question to be done. You'll see how nice it is. All right, 5.41, we're given that a sluice gate is in the form of an isosceles triangle, okay, which is 5, is vertically placed, right, with its vertex down in the canal of the same shape. All right, this is what we have. We are given our sluice gate, which is 5, in the shape of what? Of an isosceles triangle. And we know the properties of an isosceles triangle, but we're given that the vertex is given down. The vertex is the end like this. This is the vertex, but this vertex is given down. That is what you're given there. So you're given the vertex, which is the corner of one triangle facing down like this. That is the condition that we are given there, right? The vertex placed, the isosceles triangle is vertically placed with its vertex down. The vertex is down. That is the condition, right? In the canal. Remember, there are two things: the sluice gate and the canal. The sluice gate is the one that is in the form of what? An isosceles triangle, which just take it like a tank, right? A tank in the form of a triangle, then you place it in a canal. Okay, this is what we have here. What I don't, guys, on this part, if you just understand this, we are done with this topic. We are done telling you the truth, especially on this part. This is your x-axis, your y-axis. So this is what we have. The canal is this part, right? This is where we are going to place this. We are going to place it into the canal. Are we together there? Okay, so we're going to place this into the canal. So we have the properties now. Now they're saying the height of the gate, which one? The sluice gate, which is what? Our isosceles triangle. So they are saying the height of it is what? Is 4 meters. 4 meters, take note. Guys, do not confuse this. The height of the gate, which is this one in the form of an isosceles triangle, its height is the one that is 4 meters. So the height is on the triangle. This is what we have here. The height here is 4 meters. Okay? Okay. This is it. Take note. Then, and the depth of water in the canal. Take note there. The depth of water in the canal is, this is what we have now. This is our canal, this one. This is our canal. So you're going to place this into the canal, and the height of the canal, which is the depth, as we are starting from 0, going down, you are going to be limited only up to -4. It cannot go beyond that. That is our canal. And the height of the triangle is also 4 meters. So there's 4 meters of the canal. There is 4 meters of this triangle. So if you place this, guys, let's be honest. If we place this triangle here like this, it is going to be like this. Covered as it is the 4 meters, is it the 4 meters? So what does it mean? It means it is full of water. We're talking about a condition where it is considered as it is full of water, since the height of the tank is equal to the depth of the canal. So it is full of what? The tank is full of water, since here the height of the tank, which is the gate, in this case, our sluice gate, is equal to the depth of the canal. These two, they are equal. So it means we are considering this as full of what? Full of water. So our tank, or the sluice gate, is going to be considered to be here at this point. But it can be like this. And the reason why I'm explaining this is that they can give us a triangle like this. You see what we're given here? Our triangle has got a height of 4 meters. But they can give us here this one. they can say the depth of the water in the canal is 7 meters. Instead of them writing 4 like this, they'll give us as 7 meters. What does it mean? It means from this point up to this point, it is 7 meters. So it is at -7. That is where the canal is ending. So if you place this triangle into the canal, it is going to cover from -7, but it is not going to reach the water surface. Why? Because its height is 4 meters, but the canal is 7 meters high. So the triangle is going to cover only 4 meters, which it has on its height here. So if it covers 4 meters from -7, if we go up 4 units, if we add 4 units there, we get what? -3. So the triangle is going to be starting at -3, ending at -7, where the canal is ending. Because if you place it in the canal, it is going to be at the bottom part of the canal. So we start to calculate from the bottom part going up. So it's a condition where we are simply saying the sluice gate is placed 3 meters below the water surface, or the tank is 3 meters below the water surface. They can ask it that way, or they can give you different heights, all right? The height of the triangle different to the depth of the canal. On that condition, you see that there is going to be what? There is going to be a distance left. But on this one, there is no distance left. It is full of water. So meaning to say our diagram is going to be like this. We are going to have our triangle this way, covered from 0 to -4, because the height, also the depth of the canal is also 4 meters. So it will be covering up to this point like this, right? So this is the height of the gate, and also the depth of the canal, which is at what? Which is at -4, which is this height. All right. So we have talked about 2 things at the same time. It covered the height of the tank and also the what? The canal. So that is, our tank is full of water when it is like this. It is a normal condition that you're gonna consider like that. And we are given that the gate is 4 meters wide. This is how wide the gate is. This is our gate. So they are saying it is 4 meters from this point up to this point. It is what? 4 meters wide. This is high, 4 meters high. To be wide is the width. All right. So if it is 4 meters, and we know that the y-axis, it divides our shape into 2 equal parts. It's an isosceles triangle. So it's divided into 2 equal parts. So instead of us having 4 meters, we are going to have what? Divide this by 2. So it's going to be 2 meters this side, 2 meters this side, so that we can have a point here. The length is 2 meters. So at this point is 2, as we know that the y value is 0. And this point we have it, which is 0 for the x, and the y value is what? It's -4. So it's a point on its own. Yes, you can also use this side, but which is the same. That's why I explained that these 2 are the same, right? These 2 are simply the same. If you consider this, the area this side and the area this side is the same. I explained about that. So you do not waste much time working with this side, just work with one side. So I'm going to work with the left hand side to find our relationship between x and y. So that's from the left-hand side. We can just take 2 points, and this is an advantage of a type of equation. If you're someone who is used to the properties of a straight line, all right, this was an advantage type of equation here. Remember, we need the relationship. This is what we need here. We're gonna need this to have a relation between what? 2 variables, x and y. And I said on this one, you are going to have x in terms of y, all right? So like I was explaining, that it's an advantage type of equation that we are given here. Why am I explaining? So if you're someone who is used to straight lines, we know that we are supposed to find the equation of a straight line, all right? Y is equal to mx plus c. That's what you understand. where m is the gradient, the increase in y over the increase in x. So instead of just using points, I can just use that idea. The increase in y, I'm going up 4 units. X, I'm going to the right, it's a positive. So it's positive 4, positive 2. I'm going up, that's a positive. I'm going to the right, that's a positive. So it's 4 over 2. That's I've got a gradient of what? A gradient of 2. So y is equal to 2x. C represents the y-intercept. The y-intercept is at this point at what? At -4. So I'm simply substituting -4. I'm done. I do not need like a lot, but I'm not saying it's bad for you to use the points. Yes, you can use the points. The 0.20, you calculate your gradient properly. Remember, the gradient m is equal to the change in y over the change in x. You subtract the y values, -4 minus 0 over the x values, 0 minus what? 0 minus 2. So that would be -4 over -2, which is a 2. We've got your m. Then we substitute y is equal to 2x. See this one, guys. You can substitute any point, but as you can see clearly, your C is the y-intercept. So on this case, you could have also taken advantage of that, that C represents the y-intercept. So you can just substitute direct. So that's the relationship. But this relationship, I want you to be clear about this. The relationship that you're given is limited for x. Because on your integrals, you are supposed to have the integral that is going to affect with respect to y. So it's not just a relationship that you're supposed to have. It's a relationship that is limited to x. You are supposed to have it in terms of x because this is supposed to be an integral happening in terms of y. So you're supposed to make x the subject. By making x the subject, we're going to have y plus 4 is equal to 2x. I'm going to just do this one fast, guys. We have worked this type of equation before. Divide by 2, each and every part. So x is equal to y over 2 plus 2 into this, that's a 2. All right, so that's the value of x. This one is a repetition, I think. If you check April, it must be April or something, not April, but I think we talked about that question. We did a similar question. So that's why I'm saying this one is a repetition. So that's it, guys. We've got our relationship. X is equal to y over 2 plus 2. All right, let's move on to the other part of the question. What we want now is to calculate using our integration 5.42. Calculate by using integration the area moment of the sluice-gate about the water level, about the conditions that we are given before. That is what they're simply saying. So we know that in this case, the area moment is simply the integral of this 5.42. From your formula sheet, the area moment with respect to x is equal to the integral of r dA, given a and b as your limits. All right, whereby r is the distance that we are taking from the x-axis. So our distance from the x-axis referred to as y is going to be from the x-axis, remember? So that's the integral of y times dA is the area expression. Our area expression for dA is given as x dy, right? But there are two areas which are the same. This area and this area, they're the same. So this is going to be 2xy. So we are going to have this as 2x dy. All right. Explain this part also for the area concept. The multiplication of 2 is because we have got two areas which are the same. So your area expression was supposed to be just the integral of x with respect to y. But because there are two of them, this side, remember, we could have used this side to calculate the relationship. We could have worked from this side. So you could have done this. You calculate its area. You also do this. You calculate the area. You combine the areas together. So instead of doing that, you just combine it on the formula. So that's it. We've got the limits, our a and b. So now you're going to substitute. So it'll be 2, the integral of a and b being the limits. So we're going to substitute our lower limit to the upper limit. Lower limit at -4. But remember, at this point, will be at 0. So that's 0 minus 4 y times, remember we have taken these two out of the integral, so we are left with x, and our x is the one that we got from our relationship here, which we got as y over 2 plus 2, like that. So you're going to integrate this with respect to y. So that's it, we are done. So that's in the integral of, that will be 0 minus 4. You can expand by y here, each and every term. That's y times y over 2. It will be y squared over 2. Y times 2, this is going to be 2y like this. You integrate this with respect to y, you are done. From our integrals, we know that the integrals is simply the idea of adding 1 to the exponent. All right, so we are simply adding a 1 here. So that will be y to the exponent of 3 over, we multiply, that will be 3 times 2, which is a 6, all right? We do the same thing here, that will be 1, already it's a 1, so 1 plus 1 will be 2. So it was supposed to be 2y to the exponent of 2 over 2, and this will cancel. We remain with what? With y squared. Our limits taken from 0 to -4. So that is the whole idea of your question. So from this, we're done. We just have to substitute our limits, upper limit minus the lower limit. We have got our area moment, which is the first area moment, according to what we are given. Guys, by just looking here, if we substitute a 0 in place of y, that's a 0 there, that's a 0 there. So that means the first part, the upper limit is going to be a 0 minus the lower limit. When this is -4, so it's going to be -4 to the exponent of 3 over 6 plus y here, that's -4 to the exponent of 2, like this. All right, so we're going to close this bracket, or let me just do it like this so that we do not confuse these brackets that we are having here. All right, so this is the bracket for subtracting our lower limit from what? From the upper limit that we had. All right, then we are going to close the first bracket, this one. All right, so that was the idea of the question. So if you are to simplify this properly, let me take it this way. All right, this is going to give us a 2. So this will be equal to 2 into, that's 0 minus the whole of this part is going to give us 16 over 3. That's 16 over 3, which is going to give us -16 over 3 times 2, which is -32 over 3. This is the area moment, which is cubic units. So it's going to be cubic meters. These are cubic units, or you can even have it as a decimal. That will be something like -10,667. If you round off to 3 decimal places, all right? That's what you're going to have at the end. So if you check properly, you'll see that your integrals are the major part of your question, even though you have to understand properly your diagram and the formulas that you're using, because without the proper knowledge of the diagram, if this diagram is wrong, everything is wrong. That is the disadvantage of this. All right, let's check the other part, but that's the idea then. Now they need us on 5.43, calculate by using integration. Again, that's the whole part, integration. All right, but what we need now, the second moment of area, right, of the sluice gate, about the water level, as well as the depth of the center of pressure of the gate. All right, so we've got two things there. Second area moment, as we know that our second area moment is simply taken from our area moment formula, just that we have to square this. All right, so that's 5.43. So our second area moment, all right, our second area moment is simply going to be the integral of, just going to square this. So that's r squared dA. So if you know the first one, the second one is direct. So that's it. Everything, nothing is going to change. So this means if this was y, this is going to be y squared. So that's y squared AB. Our area expression as it was 2x, because you're talking about two areas at the same time. So it's 2x dy. So everything, this one is just a continuation, a repetition. So it's going to be the integral. You substitute your limits, take your 2 outside, substitute your limits, -4 up to 0 of y squared times, remember we've taken the 2 out. So it means we are left with x, and our x is not changing. Our x is still given as y over 2, just like this part, all right? Our x as it is y over 2 plus what? Plus 2 with respect to y. Then from here now we can integrate. All right, so that's it, simple as that. So this will be 2, 0, minus 4. Y times y here, this is to the exponent of 1, you add. So that's y to the exponent of 3 over 2. This is same as y over 1. So you multiply 1 times this is a 2. Y times y, y squared times y, that's y to the exponent of 3. Then if you multiply this, y squared times 2, that will be 2y squared. So that's the only difference that we are having to say. Here we are integrating this previously. Now we are integrating this. But the idea is simply the same. The integrals and so forth, you just add a 1 like that. So if we add 1 on our exponent, that will be a 4. If we add a 1 here, so that's y to the exponent of 4 over, you divide. So you're going to multiply by 4 here. 2 times 4, which is 8. Plus, you do the same thing. You add 1 here, that will be a 3. So this is 2y to the exponent of 3 over, you divide by the new exponent, which is 3. Then our limits, do not forget, from 0 to what? From 0 to minus 4. Just like that. Just like that, we're done. All right, so it was a simple question from August 2023 exams. As we can see, it was a simple question if you check properly. So here we just have to substitute everything properly. There's 2 into the upper limit. As we can see, that's a 0 there, a 0. There's nothing there, so it's just going to be a 0 minus. We substitute our lower limit. In place of y, we're going to substitute a minus 4. So this is minus 4 to the exponent of 4 over 8. Make sure that you use your calculator properly there. And this is 2 into negative 4 to the exponent of 3, everything over 3, like that. So like I said, make sure you use your calculator properly on this stage. That will be 2 into, that's 0 minus, it's going to be a negative 32 over 3. That's 32 over 3, yeah. 32 over 3, like this. It's going to be a negative. So there we've got negative, 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 negative. Definitely it's going to be a positive. So you get a positive there. You multiply by 2. That will be 64 over 3. All right, this is the second area moment. That's to the exponent of 4. All right, but the question was not ending there on calculating only the second area moment. Like I said, there's nothing. It's only that here r is being squared only. So if you understand this interpretation, the second one is just a direct part. But you're not asked this only. They also need us to calculate here as well as the depth of the center of pressure. So we are going to calculate the depth of center of pressure. Remember, that's the second area moment over the first area moment. So we have got this. We calculated here our first, this was our first area moment here. You can take it as a decimal or as a fraction. Then when we calculated this one, remember here, let me go back here. This was our second area moment here. So this side is our second area moment. So I'm just going to put it down here. All right. That's at this point. I'm just going to substitute this. So therefore, on this side, we're going to have the center of pressure given as from our second area moment over our first area moment. All right. The second area moment is this one. You can write it as a decimal if you want. So I'm just going to take it as a whole number. As a fraction as it is 64 over 3 to the exponent of 4, everything over what? The first area moment, which is, I'm going to take a fraction also, negative 32 over 3. Yes, you can use those decimals, is fine. Negative 32 over 3. So this is negative 32 over 3. If you check, there's something that is just happening there. But do not worry. Your calculator is going to solve it. All right. But there's a 3 that is happening, 3 there. So you see that if you calculate this, the center of pressure there is going to be a -2. All right, so this is going to give us -2 meters. Remember, these are cubic meters, so to cancel this, remain with what? Meters. And the negative, I always say, I explained this, the negative, it is simply because our diagram is taken below the x-axis. Remember, you can have our diagram above of the x-axis. So that's where the negative concept is simply coming from. That's why we get a negative, which is the one that we had from our first area moment. Remember here, our first area moment, it was a negative. Okay, so this is what you need to expect in your syllabus. We shall have more questions. I promised that if you follow this, a distinction is coming actually in mathematics. So also to have that a perfect distinction, make sure that you join the membership. All right, if you join the membership, you've got access to ask even questions of your choice. As long it's mathematics N6, we have got you covered up to exams as a family from Mason African Motives till we meet again.